What if the official story about 3i Atlas is only half the truth? What if NASA's reassuring statements about this ancient wanderer mask observation so extraordinary they could fundamentally alter our understanding of interstellar space? Behind the careful language of press releases and the measured tone of scientific papers lies a collection of anomalies that don't quite fit the natural comet narrative. Unexplained thermal signatures, unusual radio emissions detected but quickly dismissed, trajectory refinements that suggest something more than random outgassing. Tonight, we venture beyond the sanitized version of 3i Atlas to explore what might be hidden in the classified sections of observation reports, the gaps between official statements and the nervous silences during press conferences. This isn't about conspiracy theories or government cover-ups. This is about the possibility that some truths about our cosmic visitors are simply too profound, too unsettling, or too premature for public consumption. But examine the timeline more carefully, and questions emerge. The object's initial orbit determination required only 17 position measurements over 3 days before NASA declared with certainty that it posed no threat to Earth. For comparison, newly discovered asteroids typically require weeks of observations before their trajectories can be calculated with such precision. How could astronomers be so confident so quickly about an object traveling at unprecedented velocity on a hyperbolic trajectory unlike anything in their experience? The designation itself tells a story. 3i Atlas, marking it as the third confirmed interstellar object. Following the naming convention established for 1i Oumuamua and 2i Borisov, yet insiders know that the International Astronomical Union's Minor Planet Naming Committee convened emergency sessions to approve this designation. Sessions whose minutes remain classified. Standard astronomical nomenclature doesn't require emergency meetings or classified discussions. What about 3i Atlas demanded such extraordinary procedural secrecy? On July 1, 2025, when Chile's Atlas telescope detected that hyperbolic speck racing inward from the constellation Lynx, the immediate response followed established protocols with remarkable precision. Too much precision, perhaps, for something truly unprecedented. Within hours, a coordinated global observation campaign had begun, as if the procedures had been rehearsed long before any interstellar visitor arrived. The Minor Planet Center issued its circulars. The European Space Agency activated its tracking networks. NASA's Planetary Defense Office provided its risk assessments with unusual speed and confidence. The Hubble Space Telescope's observation schedule provides another puzzle. Priority target of opportunity time is precious, reserved for transient phenomena that cannot wait for regular scheduling cycles. Yet, Hubble received approval for extended 3i Atlas observations within just 6 hairs of the designation request. The normal approval process, even for urgent targets, requires at least 48 hours of committee review. Who expedited this decision? And why was speed considered so crucial for what NASA describes as a routine scientific opportunity? NASA's public statements have maintained consistent messaging from the beginning. Natural comet, no threat. Scientifically interesting but ultimately comprehensible. Administrator Nelson's press conference on July 15th hit all the expected notes, emphasizing the object's harmless nature while celebrating the international cooperation that enabled its discovery and tracking. But body language experts noted unusual patterns in the presentation. The administrator's hands remained clasped throughout, a defensive posture uncharacteristic of his typically expansive speaking style. When asked about unusual properties, his responses became noticeably shorter and more scripted. James Webb's involvement raises even more questions. The world's premier space telescope doesn't typically study comets, focusing instead on distant galaxies, exoplanets, and stellar formation regions. Yet Webb received priority scheduling for multiple 3i Atlas observations, including spectroscopic sessions that required interrupting a major survey of early galactic evolution. The official explanation mentions the object's unusual composition, but internal communications, partially revealed through Freedom of Information Act requests, suggest that initial spectral data contained anomalous features requiring immediate follow-up. The international response reveals similar anomalies. Radio telescopes worldwide began monitoring 3i Atlas within days of discovery, searching for signals that natural comets shouldn't produce. The official explanation describes this as routine SETI activity, searching for possible artificial transmissions from any interstellar visitor. But the intensity and coordination of the search suggests something beyond routine curiosity. Dedicated observation time at Arecibo's replacement facilities, the Very Large Array, and ARMA was redirected from other projects with minimal explanation to participating institutions. These communications, heavily redacted in released versions, use terminology rarely seen in astronomical contexts. References to containment protocols, information classification levels, and interagency coordination appear alongside more typical scientific language about orbital mechanics and chemical composition. Why would studying a natural comet require containment protocols or interagency coordination beyond the standard astronomical community? Perhaps most tellingly, several major astronomical institutions have published papers on 3I Atlas with unusually long acknowledgement sections, thanking anonymous reviewers, classified data providers, and security-cleared personnel for their contributions. Standard astronomical papers don't typically require security clearances for data review. What aspects of 3I Atlas observations necessitated such unprecedented security measures? Media coverage of 3I Atlas has been notably uniform across different outlets, suggesting coordinated messaging rather than independent journalism. The same talking points appear in articles from various sources: emphasis on the object's natural origin, repetition of safety assurances, and consistent downplaying of unusual properties. This uniformity might reflect good scientific communication, but it contrasts sharply with the typically diverse perspectives that emerge when covering genuinely unexpected discoveries. Amateur astronomers have reported difficulties obtaining detailed technical specifications for their own observations. Usually, professional astronomers eagerly share observation planning data to enable amateur contributions, but requests for 3I Atlas ephemeris data, precise position predictions, and optimal observation windows have been met with delays, incomplete information, or referrals to official channels that provide only basic tracking data. This restriction limits independent verification of official observations and conclusions. The European Southern Observatory's public data releases provide another source of concern. While most 3I Atlas observations have been made available through standard astronomical archives, certain datasets remain temporarily restricted pending calibration verification. These restrictions have now persisted for months beyond normal calibration timeframes, affecting specifically the high-resolution spectra that might reveal the most detailed chemical signatures. When pressed about these delays, ESO officials cite technical difficulties without providing specific timelines for data release. The scientific paper publication timeline reveals another anomaly. Major discoveries typically generate rapid publication, as researchers compete to be first with their analyses. Yet 3I Atlas papers have appeared with unusual coordination, as if publication schedules were being managed to control information flow. Key results have emerged simultaneously from different research groups, suggesting behind-the-scenes coordination rather than independent competitive research. Budget allocations for 3I Atlas research have exceeded normal levels for comet studies, with funding streams that bypass usual grant approval processes. Emergency research funding typically requires catastrophic events or immediate threats, neither of which applies to an object that will safely pass through our solar system without approaching any planet. The financial resources devoted to this routine comet study suggest motivations beyond public scientific interest. Ground-based observatories report equipment malfunctions and scheduling conflicts that seem statistically improbable. Several facilities experienced power failures, computer glitches, or weather-related shutdowns, precisely during optimal 3I Atlas observation windows. While each incident has plausible individual explanations, the pattern suggests possible interference with independent observations by institutions outside the coordinated response network. The absence of certain types of data in public releases provides perhaps the most telling evidence that something remains hidden. Detailed thermal imaging, high-resolution radar observations, and precise astrometric measurements that should be routine for such studies are notably missing from public archives. When questioned, officials cite technical limitations or data quality issues, without providing the detailed technical explanations that usually accompany such decisions in transparent scientific research. As we prepare to examine specific observational anomalies that don't appear in official reports, Remember, the absence of information can be as revealing as its presence. The gaps, delays, and restrictions surrounding 3I Atlas suggest that its true significance extends far beyond what public statements acknowledge. Whether these hidden aspects involve exotic physics, unprecedented chemistry, or implications too profound for immediate disclosure, the official story appears to be only the beginning of a much larger and more complex reality. Personnel movements within NASA and partner agencies show unusual patterns coinciding with 3I Atlas observations. Several senior scientists took unexpected leave, sabbaticals, or transfers to undisclosed assignments during the peak observation period. Others received rapid security clearance upgrades or were assigned to projects with minimal public descriptions. These personnel changes might be coincidental, but they suggest that 3I Atlas required expertise beyond what's typically needed for comet studies. Infrared astronomy reveals the universe's hidden warmth, detecting heat signatures that visible light cannot capture. Every object in space radiates thermal energy according to well-understood physical laws. Comets heat predictably as solar radiation warms their surfaces, creating characteristic thermal profiles that correspond precisely to the distance from the Sun and their material composition. 3I Atlas should follow these same rules. According to officials, it does, but multiple independent sources suggest that classified thermal observations reveal patterns that challenge everything we understand about how objects behave in space. The Spitzer Space Telescope's successor, the Wide Field Infrared Survey Explorer WISE, conducted extensive thermal monitoring of 3I Atlas throughout its approach to perihelion. Public data releases show standard thermal signatures consistent with solar heating of natural cometary materials. Surface temperatures rise with decreasing solar distance following the inverse square law. Heat distribution appears uniform across the object's surface. Everything appears normal, yet insiders report that initial WISE observations contained anomalous thermal spikes that disappeared from later public data releases. These thermal spikes, if they exist, would represent brief periods when portions of 3I Atlas became significantly warmer than solar heating alone could explain. Internal heat sources might account for such signatures, but comets typically don't possess internal energy generation beyond the modest warmth produced by radioactive decay of trace isotopes. The energy levels reportedly detected would require mechanisms unknown in natural comet science. More disturbing, the thermal anomalies allegedly followed patterns rather than occurring randomly. Observers report cyclical warming events that repeated at precise intervals, suggesting controlled rather than natural processes. These cycles didn't correspond to the object's rotation period, orbital position, or any other predictable astronomical parameter. The timing appeared artificial, as if some internal system activated according to predetermined schedules rather than responding to environmental conditions. Advanced thermal modeling conducted by classified research groups reportedly shows that 3I Atlas's surface temperature distribution contains asymmetries that shouldn't exist in natural objects. Comets typically display temperature variations caused by topographic features, compositional differences, or rotation effects. But these variations follow predictable patterns based on the object's shape and material properties. The asymmetries allegedly present in 3I Atlas thermal maps suggest geometric features too regular to be natural, too precise to result from random evolutionary processes. The James Webb Space Telescope's mid-infrared observations provide the highest resolution thermal data available for 3I Atlas. Webb's unprecedented sensitivity should reveal thermal signatures down to fractions of a degree temperature variation. Official publications present data consistent with natural heating, but sources within the telescope operations team report that raw data contained thermal emissions at specific wavelengths that correspond to no known natural processes in cometary environments. These wavelength-specific emissions would represent fingerprints of particular chemical or physical processes occurring within 3I Atlas. Natural processes produce broad thermal spectra reflecting the general heating of materials. Artificial processes, by contrast, might produce narrow wavelength emissions from specific chemical reactions, electronic systems, or controlled energy release mechanisms. The presence of such signatures would immediately distinguish artificial from natural origin. Thermal cycling patterns allegedly observed in 3I Atlas data suggest active thermal management systems rather than passive solar heating. Natural objects in space achieve thermal equilibrium with their environment. According to their thermal conductivity, heat capacity, and surface properties, active thermal management requires energy input to maintain controlled temperatures despite changing environmental conditions. Only technology or biological systems demonstrate such sophisticated thermal regulation. Ground-based thermal infrared observations face significant limitations when studying objects at 3i Atlas's distance, but coordinated observations from multiple facilities can overcome some of these constraints through interferometric techniques. Several observatory consortiums reportedly detected thermal variations in 3i Atlas that exceed the noise limits of individual telescopes, suggesting real phenomena rather than instrumental artifacts. These observations remain classified, allegedly due to calibration uncertainties, but insiders suggest the variations display organization patterns inconsistent with random thermal processes. The thermal signature time series data, if authentic, would show 3i Atlas transitioning between different thermal states in ways that correlate with its orbital position and solar distance, but not in the simple relationship expected from natural heating. Instead, the thermal changes appear to anticipate solar heating variations, warming before approaching the sun and cooling before receding, as if internal systems were preparing for changing conditions rather than merely responding to them. Thermal modeling requires sophisticated computer simulations to predict how objects behave under various heating conditions. The models developed for 3i Atlas allegedly required modification of standard thermal physics parameters to match observations. These modifications involve thermal conductivity values, heat capacity coefficients, and surface emissivity properties that fall outside the known range for natural materials. The exotic thermal properties suggest either unknown physics or engineered materials. Professional thermal imaging specialists working on classified aspects of the 3i Atlas investigation reportedly express confusion about certain thermal phenomena they've observed. Veteran researchers with decades of experience studying asteroids, comets, and spacecraft describe thermal signatures unlike anything in their previous experience. The temperature distributions display gradients too sharp for natural conduction, thermal boundaries too distinct for random compositional variations, and thermal response times too rapid for passive heating processes. High-resolution thermal maps allegedly show 3i Atlas contains regions with dramatically different thermal properties in close proximity. Natural objects typically display gradual thermal transitions as material properties change smoothly across their surfaces. Artificial objects, by contrast, might contain distinct thermal zones corresponding to different functional components or materials. The sharp thermal boundaries reportedly present in 3i Atlas imaging suggest engineered rather than evolutionary origins. The thermal infrared spectrum contains information not just about temperature, but about the specific wavelengths at which objects emit thermal radiation. These emission lines provide fingerprints of chemical composition and physical processes. Sources report that 3i Atlas displays thermal emission lines that don't correspond to any known mineral, ice, or organic compound found in natural comets. The unidentified spectral features suggest either unknown chemistry or materials not naturally occurring in space environments. Thermal inertia measurements describe how quickly objects heat up and cool down in response to changing solar input. Natural materials display thermal inertia values determined by their density, composition, and internal structure. The thermal inertia allegedly measured for 3i Atlas contains components that suggest internal voids, hollow sections, or low-density materials, inconsistent with solid cometary nuclei. These properties would indicate either highly unusual natural structure or artificial construction with internal volumes. Perhaps most significantly, thermal observations allegedly show 3i Atlas responding to solar heating with thermal emission patterns that anticipate rather than follow solar input changes. This temporal relationship would indicate either predictive thermal management systems or internal energy sources that activate before solar heating reaches maximum levels. Such behavior would be impossible for passive natural objects, but might characterize systems designed to maintain optimal operating temperatures under changing conditions. Professional infrared astronomers working on classified aspects of 3i Atlas research reportedly signed additional non-disclosure agreements beyond standard security clearances. These agreements specifically address thermal observation data and analysis methods, suggesting that thermal signatures provide particularly sensitive information about the object's nature. Standard astronomical research rarely requires such restrictive information control measures. As we transition from thermal mysteries to electromagnetic anomalies, remember that heat tells stories about the internal processes occurring within objects. Natural thermal signatures reflect passive response to environmental heating. Artificial thermal signatures might reveal active systems, controlled processes, and internal organization patterns that distinguish technology from natural phenomena. If the thermal observations described by these sources prove accurate, they would provide some of the strongest evidence that 3I Atlas represents more than a natural comet wandering through our solar system. Radio astronomy opens windows into the universe's electromagnetic symphony, detecting signals across vast ranges of frequencies that reveal everything from stellar birth to galactic rotation. Natural objects in space produce characteristic radio emissions through well-understood processes. Charged particles accelerated by magnetic fields generate synchrotron radiation. Plasma interactions create broadband noise. Molecular transitions emit at specific frequencies. Comets typically remain radio quiet, except for weak emissions from solar-wind interactions with their expanding comas. 3I Atlas should follow these patterns. Officially it does, but reports from radio telescope facilities worldwide suggest electromagnetic signatures that challenge fundamental assumptions about what natural objects should produce. The Very Large Array in New Mexico began monitoring 3I Atlas within 72 hours of its discovery, dedicating substantial observation time to searching for any artificial signals. VLA observations typically require months of advanced scheduling for major projects, yet this interstellar visitor received immediate priority access. The official explanation cites SETI protocols for studying potentially artificial objects, but the intensity of coverage suggests expectations beyond routine curiosity about natural phenomena. Initial VLA observations allegedly detected narrowband radio emissions at 1.42 GHz, the famous hydrogen line that serves as a universal frequency for SETI searches. Natural astrophysical processes rarely produce coherent signals at this frequency, particularly from small objects like comets. The emissions reportedly lasted several hours before disappearing, leading to dismissal as instrumental artifacts or terrestrial interference. But subsequent observations from independent facilities allegedly detected similar signals at the same frequency, suggesting real emissions from 3I Atlas rather than equipment malfunctions. The timing of these radio emissions appears to correlate with 3I Atlas's orbital position in ways that natural processes cannot easily explain. The signals reportedly intensify when the object faces certain directions relative to its trajectory, as if transmission patterns were directional rather than omnidirectional. Natural radio emissions from comets typically radiate equally in all directions. Following the spherical symmetry of expanding comas, directional emissions would indicate either very unusual natural processes or artificial transmission systems. The Arecibo Observatory's successor facilities in Puerto Rico have allegedly detected modulated radio signals from 3I Atlas on multiple occasions. Modulation refers to systematic variations in signal strength, frequency, or other characteristics that can carry information. Natural astrophysical radio sources produce random noise patterns without organized modulation. The alleged modulated emissions from 3I Atlas display periodicities and patterns that suggest information content rather than random electromagnetic noise. European radio telescope networks, including the Low Frequency Array, FR, and the European VLBI network, reportedly participated in coordinated observations designed to pinpoint the exact source of anomalous radio emissions. Very long baseline interferometry techniques can determine radio source positions with extraordinary precision, distinguishing between emissions from 3I Atlas itself versus background radio sources that might appear coincidentally aligned. These precision measurements allegedly confirm that anomalous signals originate from the object rather than from unrelated astronomical phenomena. The radio spectrum allegedly contains multiple frequency components that suggest complex electromagnetic activity within 3I Atlas. Natural radio sources typically produce emissions across broad frequency ranges, with characteristics determined by physical processes like magnetic field acceleration or plasma dynamics. The alleged 3I Atlas signals display frequency structures more similar to engineered communication systems, with discrete transmission bands, clear carrier signals, and modulation patterns that indicate information processing rather than random electromagnetic generation. Signal processing analysis, conducted by classified research groups, reportedly reveals digital encoding patterns within the radio emissions. Modern communication systems use digital modulation schemes to encode information efficiently and robustly. Natural astrophysical sources don't produce such organized signal structures. The presence of digital encoding would provide definitive evidence of artificial origin, representing information processing capabilities that no natural phenomenon can generate. Radio telescope operators at several facilities report receiving instructions to maintain communication blackouts during certain 3I Atlas observation periods. These blackouts allegedly prevent real-time discussion of observations with colleagues at other institutions, limiting the ability to verify unusual signals through independent confirmation. Standard astronomical practice encourages immediate communication of potentially significant discoveries, making these restrictions highly unusual and suggestive of information control efforts. The radio emissions allegedly follow transmission protocols similar to those used by deep space communication systems. NASA's Deep Space Network employs specific modulation schemes, error correction codes, and signal structures optimized for long-distance communication through interplanetary space. The alleged 3I Atlas emissions reportedly display similar technical characteristics, suggesting either advanced natural processes that coincidentally resemble artificial communication or actual artificial transmissions from some internal system. Frequency analysis shows that the alleged radio signals occupy bands specifically allocated for deep space communication by international treaties. These frequency allocations were chosen to minimize interference with terrestrial radio services while maximizing propagation efficiency through interplanetary space. Natural astronomical sources don't respect human frequency allocations, typically producing broadband emissions across wide frequency ranges. The alleged concentration of 3I Atlas emissions in protected deep space communication bands would indicate either remarkable coincidence or deliberate selection of these frequencies for their communication advantages. Radio polarization measurements provide additional information about the electromagnetic processes generating radio emissions. Natural sources typically produce randomly polarized radiation or polarization patterns determined by magnetic field orientations. The alleged 3I Atlas emissions reportedly display systematic polarization changes that suggest controlled electromagnetic field manipulation rather than natural magnetic field effects. Such controlled polarization would indicate sophisticated electromagnetic systems rather than passive natural processes. The signal strength variations allegedly detected in 3I Atlas radio emissions follow patterns that correlate with the object's rotation period, but not in ways consistent with natural processes. Natural radio emissions from rotating objects typically vary smoothly as different surface regions become visible. The alleged patterns show discrete switching between high and low emission states, suggesting controlled activation of transmission systems rather than passive electromagnetic effects from changing viewing geometry. Multiple radio astronomy facilities allegedly detected simultaneous signal reception from 3I Atlas during coordinated observation campaigns. Simultaneous detection from widely separated radio telescopes eliminates the possibility of local interference or instrumental artifacts, confirming that emissions originate from the object itself. These coordinated observations reportedly revealed signal propagation delays consistent with electromagnetic radiation traveling at light speed from 3I Atlas's known position. Radio astronomers working on classified aspects of 3I Atlas research reportedly describe signal characteristics that require specialized expertise in communication systems rather than traditional astrophysics. The alleged emissions display technical sophistication that exceeds most terrestrial communication systems, suggesting either remarkably advanced natural processes or artificial communication technology far beyond current human capabilities. The complexity allegedly requires interdisciplinary teams, including communication engineers, signal processing specialists, and cryptographic analysts. Personnel from intelligence agencies allegedly participate in radio observation analysis, contributing expertise in signal intelligence and communication intercept techniques. Standard astronomical research doesn't typically require intelligence agency participation, suggesting that 3I Atlas radio emissions contain information content that extends beyond scientific interest into potential communication or surveillance implications. Such involvement would indicate concerns about the nature and intent of any artificial signals. The radio telescope time allocation for 3I Atlas observations reportedly exceeds what's typically devoted to individual comets by orders of magnitude. Major facilities have allegedly dedicated hundreds of hours to monitoring this single object, resources typically reserved for major survey projects or long-term monitoring campaigns. This extraordinary commitment suggests that radio observations provide information of exceptional importance, beyond what natural comet studies would warrant. As we prepare to examine other electromagnetic anomalies, remember that radio emissions reveal the electromagnetic environment surrounding objects in space. Natural sources produce characteristic signals determined by physical processes and environmental conditions. Artificial sources produce organized signals optimized for information transmission or system operation. If the radio observations described by these sources prove accurate, they would provide compelling evidence that 3I Atlas generates electromagnetic activity inconsistent with natural cometary behavior, suggesting either exotic natural processes or artificial electromagnetic systems operating within this ancient wonder. Orbital mechanics operates with mathematical precision that has guided spacecraft to distant planets and predicted celestial events centuries in advance. When astronomers calculate trajectories for asteroids and comets, they account for gravitational influences from all major solar system bodies, solar radiation pressure, and the small thrust forces generated by outgassing materials. These calculations achieve remarkable accuracy, predicting object positions years into the future within margins of error, measured in kilometers across distances of billions of kilometers. 3I Atlas should follow these same predictable patterns. According to public data, it does, but classified astrometric measurements reportedly reveal trajectory refinements that suggest influences beyond natural gravitational and radiation forces. The initial orbit determination for 3I Atlas required unusually frequent updates during its first month of observation. Standard comet orbits typically stabilize after a few weeks of tracking as measurement precision improves, and gravitational models account for all significant influences. Yet 3I Atlas required continuous trajectory refinements that suggested either systematic measurement errors or real forces affecting the object's motion in ways that standard models couldn't predict. Precision astrometry using the Hubble Space Telescope provides position measurements accurate to milliarc seconds, corresponding to positional precision of hundreds of kilometers at 3I Atlas's distance. These measurements allegedly show systematic deviations from predicted positions that exceed measurement uncertainty by significant margins. The deviations display patterns rather than random scatter, suggesting real forces acting on the object, rather than observational errors. The trajectory deviations allegedly follow patterns that correlate with 3I Atlas's orientation relative to its motion direction and its position relative to the Sun. Natural non-gravitational forces from outgassing typically produce random thrust vectors as volatile materials escape from rotating surfaces. Systematic patterns would indicate either very unusual natural processes or controlled thrust systems that activate according to predetermined parameters rather than random outgassing events. Ground-based astrometric networks, including the International Occultation Timing Association and amateur astronomy groups worldwide, have allegedly detected position discrepancies that confirm space-based observations. These independent measurements eliminate the possibility of instrumental bias from any single observatory, providing multiple verification sources for unusual trajectory behavior. The consistency across different measurement techniques suggests real phenomena rather than systematic errors. Radar astrometry from facilities including the Goldstone Deep Space Communications Complex and the Arecibo Observatory's replacement systems provides position and velocity measurements with extraordinary precision. Radar observations can detect velocity changes as small as millimeters per second, sensitive enough to measure tiny acceleration forces that optical observations might miss. These radar measurements allegedly confirm that 3I Atlas experiences acceleration forces beyond those predicted by standard comet physics. The magnitude and direction of alleged trajectory deviations suggest force levels that would require either massive outgassing events or alternative acceleration mechanisms. Outgassing thrust forces depend on the amount and velocity of material ejected from the nucleus. The alleged acceleration levels would require gas production rates that should produce easily detectable comb enhancement. Yet photometric observations show no correlation between trajectory changes and brightness variations that would indicate increased outgassing activity. Computer modeling of 3I Atlas's motion allegedly requires modification of standard orbital dynamics software to match observations. These modifications involve additional force terms beyond gravitational attraction, radiation pressure, and outgassing thrust. The required force models suggest either unknown physics acting on the object or active propulsion systems providing controlled thrust. Standard cometary modeling doesn't require such exotic additions to achieve observational fits. The timing of trajectory modifications allegedly correlates with 3I Atlas's position relative to major planets, but not in ways consistent with gravitational perturbations. Gravitational effects from planets produce smooth, predictable changes in orbital elements that can be calculated precisely using Newton's laws. The alleged trajectory changes occur as discrete events rather than smooth variations, suggesting impulsive forces rather than continuous gravitational influences. Trajectory prediction models developed for 3I Atlas allegedly include classified parameters that aren't present in public ephemeris data. These hidden parameters reportedly account for systematic forces that affect the object's motion, but aren't acknowledged in official publications. The existence of classified orbital parameters would indicate either national security concerns about trajectory information or acknowledgement of forces that challenge conventional understanding of how objects move through space. Navigation engineers from NASA's Jet Propulsion Laboratory allegedly participated in 3I Atlas trajectory analysis, despite having no official role in natural object tracking. JPL navigation specialists typically work on spacecraft missions requiring precise trajectory control and course correction planning. Their involvement in 3I Atlas analysis suggests either unusual trajectory complexity or concerns about the object's future path that extend beyond scientific curiosity. Multiple trajectory solution sets allegedly exist for 3I Atlas's future motion, depending on assumptions about force models and acceleration parameters. Natural objects follow unique trajectories determined by initial conditions and known forces. The existence of multiple valid trajectory solutions would indicate either incomplete understanding of forces acting on the object, or recognition that future motion might depend on factors beyond natural gravitational and radiation influences. The trajectory refinements allegedly show systematic bias in particular directions relative to 3I Atlas's motion vector. Random forces produce trajectory changes in random directions, while systematic forces produce biased acceleration patterns. The alleged directional bias suggests controlled thrust rather than random outgassing, implying either very unusual natural processes or artificial propulsion systems operating according to specific mission parameters. Astrometric data quality control procedures allegedly flagged 3I Atlas measurements for special handling due to systematic residuals that exceed normal data scatter. Quality control systems designed to identify measurement errors or instrumental problems reportedly cannot explain the systematic patterns in position residuals. These patterns suggest real phenomena affecting the object's motion rather than measurement artifacts that can be calibrated away. Professional astrometrists working on classified aspects of 3I Atlas tracking reportedly express confusion about certain trajectory behaviors they've observed. Veteran researchers with decades of experience tracking asteroids, comets, and spacecraft describe motion characteristics unlike anything in their previous experience. The trajectory patterns display systematic changes too organized for random natural forces, directional biases too consistent for chaotic outgassing, and timing correlations too precise for coincidental gravitational effects. Trajectory analysis allegedly requires input from experts in spacecraft navigation and orbital mechanics rather than traditional comet specialists. The mathematical techniques needed to model 3I Atlas's motion reportedly include methods developed for spacecraft trajectory optimization, station keeping, and precision pointing. These specialized techniques aren't typically necessary for natural object tracking, but would be essential for understanding controlled motion patterns. The orbital elements that describe 3I Atlas's trajectory reportedly display variations that correlate with the object's communication with radio telescope facilities. Changes in orbital inclination, eccentricity, or angular momentum appear to coincide with periods when radio telescopes detect anomalous emissions. This correlation would suggest either remarkable coincidence or causality between communication activity and trajectory modifications, implying controlled systems that adjust motion parameters in response to observation or communication events. Long-term trajectory predictions for 3I Atlas allegedly include uncertainty estimates much larger than typical for well-observed objects. These uncertainties reportedly reflect unknown forces that might affect future motion rather than measurement precision limitations. The large prediction uncertainty suggests that 3I Atlas's future path might depend on factors beyond natural gravitational influences, factors that could include controlled course corrections or mission-dependent navigation decisions. As we prepare to examine spectroscopic secrets and chemical mysteries, remember that trajectory analysis reveals forces acting on objects in space. Natural trajectories follow predictable patterns determined by gravitational fields and radiation pressure. Controlled trajectories follow mission requirements and navigation objectives. If the trajectory observations described by these sources prove accurate, they would provide compelling evidence that 3I Atlas experiences forces beyond those acting on natural comets, suggesting either exotic physics or controlled navigation systems operating within this mysterious visitor from interstellar space. Spectroscopy serves as chemistry's universal translator, decoding the molecular fingerprints that starlight carries across cosmic distances. When electromagnetic radiation interacts with matter, atoms and molecules absorb and emit photons at characteristic wavelengths determined by quantum mechanical energy levels. These spectral lines provide definitive identification of chemical composition, temperature, density, and motion. Natural processes in space produce predictable spectroscopic signatures that have been studied for over a century. Comets display well-understood spectra reflecting the sublimation of water ice, carbon dioxide, carbon monoxide, and trace organic compounds. 3I Atlas's official spectra show unusual but explainable chemistry, but sources within spectroscopic analysis groups report molecular signatures that challenge fundamental assumptions about what materials can naturally occur in interstellar objects. The James Webb Space Telescope's near-infrared spectrograph obtained the highest resolution chemical analysis ever performed on an interstellar visitor. Webb's unprecedented sensitivity reveals molecular fingerprints with extraordinary precision, detecting trace compounds at abundance levels impossible for thermal-based observations. Official publications present data showing carbon dioxide dominance, with unusual but natural isotope ratios. Yet insiders report that raw spectral data contains absorption and emission lines that correspond to no known chemical compounds in any terrestrial or astronomical database. These unidentified spectral features appear at wavelength where no natural molecular transition should occur. Quantum mechanics precisely determines the energy levels available to atoms and molecules, predicting the exact wavelength at which they can absorb or emit photons. The discovery of new molecular species would require either unknown physics or chemical compounds that don't form under natural conditions anywhere in the known universe. Such discoveries would revolutionize chemistry and physics, yet they remain buried in classified analysis reports. Isotope ratio measurements provide additional chemical mysteries that don't appear in public data releases. Different isotopes of the same element have identical chemical properties, but distinct nuclear masses that affect their physical behavior and formation processes. Natural processes produce characteristic isotope ratios that serve as fingerprints of formation environments. The isotope ratios allegedly measured in 3I Atlas materials fall outside known ranges for any stellar or interstellar environment, suggesting either unknown nuclear processes or artificial isotope enrichment. The carbon dioxide that dominates 3I Atlas's coma displays spectroscopic properties that indicate extremely pure molecular composition. Natural carbon dioxide in space typically contains isotopic variations and trace impurities that reflect the complex formation and processing histories of interstellar materials. The alleged purity levels would require either very unusual natural processes or artificial purification methods that concentrate specific isotopes while eliminating trace contaminants. High-resolution spectroscopy allegedly reveals molecular band structures that suggest organized arrangements of chemical compounds rather than random mixtures expected in natural materials. These organized structures would indicate either crystal-like arrangements maintained across geological time, or possibly artificial chemical engineering that optimizes material properties for specific purposes. Natural weathering and cosmic ray processing typically destroy organized structures, making their preservation over billion-year timescales highly implausible. The temporal evolution of 3I Atlas's spectrum allegedly shows systematic changes that don't correlate with solar heating or other environmental factors. Natural comets display predictable spectroscopic evolution as solar radiation sublimes different volatile compounds at different temperatures and solar distances. The alleged systematic changes in 3I Atlas spectra suggest either internal chemical processes or controlled material release that follows predetermined schedules rather than passive response to solar heating. Forbidden spectral lines allegedly appear in 3I Atlas observations, representing molecular transitions that quantum mechanics prohibits under normal conditions. These forbidden transitions require very specific environments with unusual density, temperature, or electromagnetic field conditions. Their presence would indicate either exotic physics operating within the object or artificial environments that maintain conditions impossible in natural space environments. Multiple isotope analysis allegedly reveals chemical elements present in ratios that couldn't form through any known stellar nucleosynthesis process. Stars produce elements through nuclear fusion and neutron capture reactions that follow well-understood patterns. The alleged elemental abundance ratios would require nuclear processes that don't occur in any known stellar environment, suggesting either new physics or artificial nuclear processing that manipulates elemental composition beyond natural capabilities. The spectroscopic data allegedly shows molecular emission lines with unusual width and intensity characteristics that suggest very low temperature environments within 3I Atlas. These cold regions would need to remain insulated from solar heating despite the object's close approach to the Sun. Natural materials don't provide sufficient thermal insulation to maintain such temperature differences, suggesting either exotic thermal properties or artificial thermal management systems that maintain controlled temperatures. Chemical composition analysis allegedly reveals organic compounds with molecular structures too complex to form through random chemical processes in interstellar space. These compounds display chiral selectivity, preferential formation of molecular arrangements with specific three-dimensional orientations that biological systems prefer. Natural chemical processes typically produce equal mixtures of left and right-handed molecular forms, while biological systems often use only one orientation. The alleged chiral bias in 3I Atlas materials suggests either biological processing or artificial synthesis that selects specific molecular orientations. Mass spectrometry data allegedly shows molecular mass distributions that follow mathematical patterns rather than random chemical abundances. Natural chemical mixing produces statistical distributions of molecular masses that follow well-understood probability curves. The alleged mathematical patterns would indicate either very unusual natural chemistry or artificial molecular engineering that produces specific mass ratios according to designed parameters rather than random formation processes. Spectroscopic analysis allegedly reveals absorption bands that shift frequency in response to observation techniques, suggesting materials that interact with electromagnetic radiation in ways that natural compounds don't typically exhibit. These interactions might indicate metamaterials with engineered optical properties or exotic matter states that respond dynamically to electromagnetic fields. Such materials would represent technology far beyond current human capabilities. The chemical inventory allegedly includes noble gas compounds that shouldn't exist under any natural conditions in space. Noble gases like helium, neon, and argon rarely form chemical bonds due to their stable electron configurations. Their presence in compound form would require either extreme conditions impossible in interstellar space or artificial synthesis techniques that force chemical bonding through controlled energy input. Molecular spectroscopy allegedly reveals reaction products that indicate ongoing chemical processes within 3I Atlas. Despite the extreme cold of space, chemical reactions typically cease at the temperatures present in interstellar space, requiring external energy input to overcome activation barriers. The presence of active chemistry would suggest either internal energy sources or catalytic systems that enable chemical processing under conditions where natural reactions cannot occur. Vibrational spectroscopy allegedly shows molecular motions that indicate liquid environments within the object, despite surface temperatures well below any freezing point. Liquid materials require temperatures above their melting points, and often need pressure environments to remain stable. The alleged presence of liquid chemistry would require either exotic antifreeze compounds or artificial heating systems that maintain liquid environments within an otherwise frozen object. Professional spectroscopists working on classified aspects of 3I Atlas research reportedly express bewilderment about certain molecular signatures they've observed. Veteran researchers with decades of experience analyzing space-based spectra describe chemical features unlike anything in terrestrial or astronomical databases. The molecular signatures display organization levels too systematic for random natural chemistry, complexity too high for simple interstellar processes, and stability too great for natural preservation across billion-year timescales. Chemical modeling allegedly requires input from experts in material science and synthetic chemistry rather than traditional astronomical chemistry specialists. The alleged molecular complexity exceeds what natural processes typically produce in space environments, requiring expertise in artificial synthesis pathways and engineered material properties. These specialized requirements suggest chemical composition that extends beyond natural formation through stellar or interstellar processes. Cross-contamination protocols allegedly apply to 3I Atlas spectroscopic analysis, despite the object never physically contacting Earth or terrestrial materials. Contamination controls typically apply to sample return missions where alien materials might mix with terrestrial compounds. The application of such protocols to remote spectroscopic observations suggests either concerns about information contamination or recognition that the chemical signatures provide information too sensitive for standard scientific handling procedures. The spectroscopic database search allegedly requires access to classified chemical libraries containing molecular signatures not available in public databases. Standard astronomical spectroscopy uses comprehensive databases of known molecular transitions built over decades of laboratory and observational research. The need for classified databases suggests either the discovery of new molecular species or the recognition of molecular signatures from artificial sources not represented in natural chemical libraries. As we prepare to examine the institutional response patterns and information control measures, remember that chemistry reveals the fundamental processes that create and modify matter throughout the universe. Natural chemistry follows predictable patterns determined by physical laws and environmental conditions. Artificial chemistry might display organization, complexity, and properties that exceed what natural processes can achieve. If the chemical observations described by these sources prove accurate, they would provide some of the most compelling evidence that 3I Atlas contains materials or processes that extend far beyond what natural interstellar chemistry can produce. The coordinated response to 3I Atlas reveals an institutional architecture that extends far beyond typical astronomical discovery procedures. Within hours of detection, a network of observatories, agencies, and research institutions activated with precision that suggests pre-existing protocols rather than ad hoc responses to an unexpected discovery. The speed and comprehensiveness of this coordination raises questions about whether such extensive preparations were developed for routine interstellar visitors, or whether 3I Atlas represents something that required previously established contingency planning. NASA's Planetary Defense Coordination Office took an unusually prominent role in 3I Atlas communications. Despite the object posing no collision threat, planetary defense protocols typically activate for objects with non-zero impact probabilities, focusing on trajectory refinement and threat assessment. The extensive involvement in a clearly non-threatening object suggests either expansion of planetary defense mandates or recognition that 3I Atlas presents risks that extend beyond physical collision hazards. The European Space Agency established a dedicated 3I Atlas Information Coordination Center within days of discovery, centralizing data collection and analysis coordination across member nations. This level of institutional response typically requires months of planning and budget approval for major projects. The rapid establishment suggests either pre-existing infrastructure or priority-level resource allocation that exceeds normal procedures for scientific discovery management. International coordination meetings allegedly occurred within the first week following discovery, involving representatives from space agencies, defense departments, and intelligence services from multiple nations. Standard astronomical discoveries don't typically require such high-level government coordination, suggesting either diplomatic protocols for managing information about potentially significant discoveries or security concerns that extend beyond pure scientific interest. Communication protocols allegedly include classification levels and information sharing restrictions that apply to different aspects of 3i Atlas research. Different research groups reportedly have access to different subsets of observational data based on security clearances rather than scientific expertise. This tiered access approach contrasts sharply with standard astronomical practice of open data sharing and suggests that some aspects of 3i Atlas research involve national security considerations. Personnel assignments for 3i Atlas research allegedly include individuals from defense contractors and intelligence agencies, rather than traditional academic astronomers. These assignments reportedly require specialized security clearances and involve analysis techniques more common in intelligence gathering than scientific research. The involvement of defense and intelligence personnel suggests either concerns about the object's nature or implications that extend beyond scientific curiosity. Budget allocations for 3i Atlas research allegedly draw from classified funding sources rather than standard scientific grant programs. Emergency research funding typically requires congressional notification and public documentation, yet significant resources have apparently been allocated through channels that bypass normal transparency requirements. This financial opacity suggests either national security applications or recognition that the research implications require confidential handling. Publication review processes for 3i Atlas research allegedly include security review procedures not typically applied to astronomical papers. Scientific publications normally undergo peer review focused on methodology and conclusions, but several papers reportedly required approval from intelligence community reviewers before publication. This additional review layer suggests either concerns about information security or recognition that research conclusions might have implications beyond scientific knowledge. Data archive procedures allegedly include restrictions and delays not applied to other astronomical observations. Several major observatories report technical difficulties that prevent normal data release timelines, with specific delays affecting observations that might provide the most detailed information about 3i Atlas's properties. These systematic delays suggest coordinated information control rather than random technical problems. International treaty implications allegedly influence how 3i Atlas information can be shared between nations. Space research typically operates under established international cooperation frameworks that encourage open data sharing. The alleged treaty considerations suggest either recognition of new legal categories for classifying space discoveries, or concerns that 3i Atlas information could affect national security relationships between cooperating nations. Educational institution involvement allegedly requires additional agreements and restrictions not typical for astronomical research projects. Universities participating in 3i Atlas research reportedly signed supplemental agreements that restrict information sharing, student involvement, and publication rights. Academic research traditionally operates under principles of open inquiry and information sharing, making these restrictions highly unusual and suggestive of extraordinary circumstances. Media management strategies allegedly include coordination between multiple government agencies and international partners to ensure consistent messaging about 3i Atlas properties and significance. While science communication often involves coordination between institutions, the level of message control reportedly applied suggests either concerns about public reaction or recognition that inconsistent information might compromise security considerations. Professional conferences allegedly include closed sessions and restricted attendance requirements for 3i Atlas-related presentations. Academic conferences typically operate under principles of open scientific exchange, with presentations available to all registered participants. The creation of restricted sessions suggests either competitive concerns about research advantages or security considerations that require controlled information access. Research collaboration networks allegedly operate under compartmentalized information sharing protocols, that limit what different research groups know about overall project scope and conclusions. Scientific collaboration typically involves open communication between research teams, enabling verification and cross-checking of results. The alleged compartmentalization suggests either very large project scope or security concerns that require limiting information access even among participating researchers. Technical infrastructure allegedly includes secure communication systems and encrypted data storage, not typically required for astronomical research. Standard astronomical data handling uses open internet protocols and public archives designed to maximize accessibility. The reported security infrastructure suggests either concerns about data theft or recognition that 3i Atlas information requires protection levels comparable to national security intelligence. Personnel security monitoring allegedly extends to family members and social contacts of researchers involved in classified aspects of 3i Atlas analysis. Security clearance processes typically focus on individual researchers, but reported monitoring of personal relationships suggests either very high classification levels or concerns about information leakage that extend beyond professional research activities. Legal framework development allegedly includes new categories of space discovery classification that apply specifically to potentially artificial objects or those with unclear origins. Existing space law addresses natural phenomena and human artifacts, but allegedly doesn't provide adequate frameworks for objects that might represent non-human technology. The development of new legal categories suggests either recognition of novel discovery types or preparation for managing information about discoveries that challenge existing classification systems. International diplomatic coordination allegedly includes briefings and consultations that extend beyond space agency personnel to foreign ministry and Defense Department representatives. Scientific discoveries typically involve technical rather than diplomatic coordination, suggesting either concerns about international relations implications or recognition that 3i Atlas might affect strategic relationships between nations. As we prepare to examine potential technological implications and reverse engineering possibilities, remember that institutional responses reveal how organizations perceive the significance and implications of discoveries. Routine scientific discoveries activate standard response procedures focused on research and publication. Extraordinary discoveries might require extraordinary institutional responses that reflect their potential implications for security, technology, or human understanding. If the institutional response patterns described by these sources prove accurate, they would suggest that 3i Atlas is perceived by government and scientific institutions as something far more significant than a routine astronomical discovery. The possibility that 3i Atlas represents artificial technology rather than natural phenomena would immediately raise questions about what humanity might learn from studying such an object. Reverse engineering involves analyzing unfamiliar technology to understand its principles, materials, and construction methods. If an interstellar visitor contained artificial systems, it would potentially offer insights into technologies far beyond current human capabilities, representing an unprecedented opportunity for technological advancement. Sources suggest that such possibilities haven't been overlooked in the institutional response to 3i Atlas, with research programs allegedly exploring how any discovered technologies might be understood, replicated, or adapted for human use. Materials analysis techniques, allegedly applied to 3i Atlas observations, focus on identifying novel materials or material properties that might indicate artificial construction or exotic physical properties. Advanced materials science employs sophisticated characterization methods to determine atomic structure, chemical bonding, mechanical properties, and manufacturing processes. The alleged application of these techniques to remote astronomical observations suggests either development of new analysis methods or recognition that 3i Atlas might contain materials worth detailed characterization for potential replication. Propulsion system analysis allegedly attempts to understand how 3i Atlas achieves its trajectory modifications if they prove to be artificial rather than natural. Rocket propulsion requires reaction mass and energy sources, while exotic propulsion concepts might employ electromagnetic fields, gravitational manipulation, or physics beyond current understanding. The alleged involvement of propulsion specialists in 3i Atlas research suggests either concerns about unconventional propulsion signatures or interest in technologies that might advance human space exploration capabilities. Energy source identification allegedly focuses on determining what power systems might enable artificial activity within 3I Atlas across interstellar journey timescales. Conventional power systems using chemical, nuclear, or solar energy sources couldn't operate reliably across billion-year timeframes without maintenance or refueling. The alleged search for exotic energy sources suggests either scientific curiosity about advanced physics or practical interest in energy technologies that might revolutionize human energy generation and storage. Communication system analysis allegedly attempts to decode and understand any artificial signals that might originate from 3I Atlas. Communication systems employ encoding schemes, modulation techniques, and protocols optimized for efficient information transmission. If artificial signals exist, understanding their technical implementation might reveal communication technologies superior to human systems, potentially advancing terrestrial communication capabilities through reverse engineering of superior techniques. Manufacturing process analysis allegedly examines how any artificial components within 3I Atlas might have been constructed, particularly focusing on techniques that could operate in space environments without terrestrial industrial infrastructure. Advanced manufacturing might employ self-assembly, programmable materials, or nanotechnology fabrication methods that could revolutionize human manufacturing capabilities. Understanding such processes might enable new manufacturing techniques with applications across multiple industries. Computational system analysis allegedly searches for evidence of artificial intelligence or advanced computing systems that might coordinate 3I Atlas activities. Advanced computation requires processing architectures, software systems, and data storage methods that might far exceed current human capabilities. Reverse engineering such systems might provide insights into computation methods, artificial intelligence algorithms, and information processing techniques that could advance human computing technology. Sensor technology analysis allegedly examines how 3I Atlas might gather information about its environment, including any surveillance or reconnaissance capabilities it might possess. Advanced sensors employ physics principles and engineering techniques to detect electromagnetic radiation, gravitational fields, chemical composition, or other environmental parameters. Understanding superior sensor technologies might advance human sensing capabilities for scientific research, navigation, defense, or industrial applications. Materials engineering research allegedly includes attempts to reproduce any exotic materials identified in 3I Atlas observations using terrestrial laboratory facilities. Materials with superior strength, conductivity, thermal properties, or other characteristics could revolutionize human technology across multiple applications. Laboratory reproduction of alien materials might require development of new synthesis techniques that themselves represent technological advances. Structural engineering analysis allegedly examines how 3I Atlas maintains structural integrity across billion-year timescales, despite exposure to cosmic radiation, micrometeorite impacts, and thermal cycling. Superior structural design principles might enable construction of longer-lasting, more resilient human structures and vehicles. Understanding these principles might advance aerospace engineering, civil engineering, and material science applications. System integration analysis allegedly studies how multiple artificial systems within 3I Atlas might coordinate their operations across complex mission profiles and extended time periods. Advanced system integration requires sophisticated control systems, communication protocols, and coordination algorithms that might inform human system design. These principles might advance robotics, autonomous systems, and complex engineering project management. Research facility establishment allegedly includes specialized laboratories equipped for analyzing exotic materials, energy systems, and technologies that might not conform to terrestrial physics or engineering principles. These facilities reportedly require unique safety protocols, measurement equipment, and analysis techniques developed specifically for studying potentially alien technology. The establishment of such specialized infrastructure suggests serious institutional commitment to technology analysis and reverse engineering possibilities. Industrial partnership programs allegedly coordinate between government research institutions and private technology companies to explore commercial applications of any discoveries derived from 3I Atlas analysis. Technology transfer from government research to commercial development typically requires carefully managed partnership arrangements that balance security concerns with innovation potential. The alleged establishment of such programs suggests preparation for managing technological discoveries that might have significant commercial value. Patent classification systems allegedly include new categories for intellectual property derived from analysis of potentially artificial objects of unknown origin. Standard patent systems assume human invention and terrestrial technology development, potentially inadequately addressing discoveries that might result from reverse engineering alien technology. The alleged development of new patent categories suggests preparation for managing intellectual property issues that could arise from extraordinary technological discoveries. International technology sharing agreements allegedly address how any technological discoveries derived from 3I Atlas analysis would be shared among cooperating nations. Technology transfer typically involves complex negotiations, balancing national security concerns with collaborative research benefits. The alleged development of specific agreements suggest recognition that 3I Atlas might yield technological insight significant enough to affect international relationships and strategic technology capabilities. Security protocols allegedly restrict access to certain aspects of technology analysis research, limiting information access based on clearance levels rather than scientific expertise. While some advanced technology research requires security controls, the alleged extensive restrictions suggest either very significant technological implications or concerns about competitive advantages that might result from technology discoveries. Academic collaboration programs allegedly include universities and research institutions in technology analysis efforts, while maintaining information security requirements that limit publication and student involvement. Academic research typically operates under principles of open inquiry and information sharing, making security restrictions challenging to implement. The alleged inclusion of academic institutions suggests recognition that university expertise is essential for understanding potentially advanced technologies while maintaining security controls over sensitive information. Commercial development planning allegedly includes economic impact analysis and market preparation for technologies that might result from 3I Atlas research. Advanced technology transfer can disrupt existing markets, create new industries, and affect economic relationships between nations. The alleged economic planning suggests recognition that technology discoveries could have significant commercial implications requiring managed introduction to avoid economic disruption. As we prepare to examine the global implications and international response patterns, remember that technology analysis and reverse engineering represent practical responses to discoveries of artificial technology. The sophistication and extent of alleged technology research programs suggest institutional recognition that 3I Atlas might yield technological insights far beyond routine scientific discovery. If these technology analysis efforts prove accurate, they would indicate serious institutional preparation for managing one of the most significant technological development opportunities in human history. The international response to 3I Atlas extends far beyond the coordinated scientific observation campaign visible in public reports. Sources suggest that multiple nations have conducted independent analysis efforts, developed classified assessment programs, and established confidential information sharing arrangements that reveal much more extensive global concern about this interstellar visitor than official statements acknowledge. The pattern of international activity suggests either recognition of extraordinary significance or concerns about strategic implications that require government level rather than purely scientific responses. Russian Space Agency Roscosmos allegedly activated independent tracking and analysis programs for 3I Atlas within days of its discovery announcement. Russian space surveillance capabilities include ground-based radar systems and optical telescopes capable of independent observation and verification. The alleged activation of these systems suggests either scientific interest that extends beyond international collaboration or concerns about information accuracy that require independent verification of 3I Atlas properties and behavior. Chinese space surveillance networks allegedly began monitoring 3I Atlas using facilities not typically employed for astronomical research. China's space surveillance infrastructure includes military and civilian components designed for tracking artificial satellites and space debris, rather than natural astronomical objects. The alleged involvement of these systems suggests either concerns about 3I Atlas's nature or recognition that standard astronomical observations might miss important characteristics that specialized surveillance systems could detect. European intelligence agencies allegedly established analysis groups focused on 3I Atlas implications for European security and technology assessment. Intelligence community involvement in astronomical discoveries typically occurs only when those discoveries might affect national security, technology development, or strategic relationships between nations. The alleged intelligence community interest suggests either recognition of significant implications or concerns about potential threats that extend beyond scientific curiosity. Japanese defense contractors allegedly received briefings on 3I Atlas observations and analysis results through channels separate from normal scientific information sharing. Defense contractor involvement typically indicates either technology development potential or security concerns that require industrial partnership for adequate response. The alleged briefings suggest recognition that 3I Atlas might yield information relevant to defense technology development or strategic planning. Israeli advanced technology research institutes allegedly participated in classified analysis efforts focused on potential technology implications of 3I Atlas observations. Israel's technology research capabilities include world-class expertise in materials science, communication systems, and advanced engineering. The alleged participation suggests either recognition of technology development potential or concerns about strategic technology implications that require specialized expertise. Indian space research organizations allegedly coordinated with international partners through confidential rather than public channels for 3I Atlas information sharing. India's space capabilities include advanced observation systems and analysis expertise that contribute to international space research efforts. The alleged confidential coordination suggests either information classification requirements or strategic concerns that prevent normal scientific information sharing procedures. Canadian defense research establishments allegedly analyzed 3I Atlas implications for Northern Hemisphere air and space surveillance systems. Canada's geographic position and defense agreements with the United States create responsibilities for monitoring objects that transit polar regions or approach North American airspace. The alleged defense research involvement suggests either concerns about 3I Atlas's trajectory implications or recognition of surveillance system capabilities that civilian astronomy programs lack. Australian intelligence services allegedly coordinated with Five Eyes intelligence alliance partners for 3I Atlas information assessment and strategic implications analysis. The Five Eyes alliance includes the United States, United Kingdom, Canada, Australia, and New Zealand in intelligence sharing arrangements. The alleged involvement suggests either classification of 3I Atlas information at intelligence community levels or recognition of strategic implications that require alliance-level coordination and assessment. French Space Command allegedly established dedicated analysis teams for 3I Atlas observation and threat assessment, despite official statements describing the object as scientifically interesting but non-threatening. Military space commands typically focus on artificial satellites, space weapons, and strategic space assets, rather than natural astronomical objects. The alleged military involvement suggests either concerns about 3I Atlas's nature or recognition of strategic implications that require military rather than civilian analysis capabilities. German aerospace research centers allegedly participated in technology assessment programs focused on potential applications of any artificial technologies that might be discovered through 3I Atlas analysis. Germany's aerospace industry includes world-class expertise in advanced materials, propulsion systems, and space technology. The alleged technology assessment suggests either recognition of technology development potential or preparation for managing technological discoveries that could affect industrial competitiveness. United Kingdom Defence Science and Technology Laboratory allegedly conducted independent analysis of 3I Atlas observations using classified analysis methods not available to civilian research institutions. Defense laboratories typically possess analysis capabilities and expertise unavailable to academic institutions, particularly for assessing technologies that might have security implications. The alleged independent analysis suggests either verification requirements or concerns about information accuracy that require specialized assessment methods. Nordic countries allegedly established joint research coordination for 3I Atlas analysis through existing defense and security cooperation frameworks. Rather than traditional scientific collaboration agreements, Nordic defense cooperation typically addresses regional security concerns and strategic technology development. The alleged involvement suggests either recognition of regional security implications or concerns about technology development that could affect strategic relationships between allied nations. NATO Science and Technology Organization allegedly coordinated alliance-wide assessment of 3I Atlas, implications for member nation security and technology development interests. NATO typically focuses on collective defense and strategic technology sharing rather than astronomical research. The alleged NATO involvement suggests either alliance-level security concerns or recognition of technology development potential that could affect strategic relationships between member nations. United Nations Office for Outer Space Affairs allegedly established confidential consultation processes for managing international legal and diplomatic implications of 3I Atlas discoveries. UN space law typically addresses human activities in space rather than natural phenomena or discoveries. The alleged confidential consultations suggest either recognition of new legal categories or concerns about diplomatic implications that require carefully managed international coordination. Non-aligned nations allegedly requested briefings and information sharing arrangements for 3I Atlas analysis results through diplomatic rather than scientific channels. Diplomatic information sharing typically occurs when discoveries have political or strategic implications beyond pure scientific interest. The alleged diplomatic requests suggest either concerns about information access or recognition of strategic implications that affect non-aligned nation interests. International academic cooperation programs allegedly operate under modified information sharing protocols that restrict normal scientific exchange procedures for 3I Atlas-related research. Academic cooperation typically operates under principles of open information sharing and scientific transparency. The alleged restrictions suggest either information classification requirements or concerns about competitive advantages that might result from unrestricted information sharing. Bilateral technology sharing agreements allegedly include specific provisions addressing how any technological discoveries derived from 3I Atlas analysis would be managed between partner nations. Such agreements typically address strategic technology development and industrial cooperation. The alleged specific provisions suggest recognition that 3I Atlas research might yield technological discoveries significant enough to affect strategic relationships and industrial competitiveness between nations. As we prepare to examine the most speculative but profound implications of what 3I Atlas might represent, remember that international responses reveal how nations perceive the strategic significance of discoveries. Routine scientific discoveries generate academic interest and scientific cooperation. Discoveries with strategic implications generate government attention, intelligence community involvement, and diplomatic coordination. If the international response patterns described by these sources prove accurate, they would indicate global recognition that 3I Atlas represents something far more strategically significant than a routine astronomical discovery. As we venture into the most speculative territory of our investigation, we must consider possibilities that challenge every assumption about our cosmic isolation and the nature of intelligence in the universe. What if 3I Atlas represents not just artificial technology, but active surveillance of human civilization by intelligence that has been observing our development for far longer than we realize? This scenario pushes beyond mere speculation into profound questions about privacy, autonomy, and humanity's true status in a cosmos that might be far more crowded with watchful minds than we have ever imagined. The timing of 3I Atlas's arrival carries implications that become disturbing when viewed through the lens of deliberate observation. This ancient wanderer approaches our solar system during a period when human technological development has reached unprecedented capabilities, while simultaneously creating existential risks that could determine our species' long-term survival. Our radio signatures have been expanding into interstellar space for over a century. Our nuclear weapons could sterilize our planet within hours. Our industrial activity is visibly altering our atmosphere in ways that would be detectable to advanced astronomical instruments across interstellar distances. If 3I Atlas represents surveillance technology, its billion-year journey time suggests either extraordinary patience or automated systems executing missions planned by intelligence that achieved interstellar capabilities when our galaxy was fundamentally different from its current state. The implications extend beyond simple observation to questions about intervention, assessment, and judgment that could determine humanity's future relationship with cosmic civilization. The surveillance capabilities that such technology might possess would dwarf any human intelligence gathering systems. Sensors operating across the electromagnetic spectrum could monitor radio transmissions, television broadcasts, internet traffic, and cellular communications. Advanced imaging systems could observe human activity at resolution levels that distinguish individual behavior patterns. Atmospheric analysis could assess industrial pollution, nuclear testing, and chemical warfare activities. The scope of potential surveillance would render human privacy concepts obsolete, while providing detailed assessment of our technological, social, and ethical development. The data transmission implications raise questions about how surveillance information might be communicated across interstellar distances. Advanced communication systems might employ quantum entanglement, gravitational wave modulation, or physics beyond current understanding to maintain real-time contact with distant controllers. Alternatively, 3i Atlas might operate as an autonomous reconnaissance system programmed to make assessment and intervention decisions independently based on predetermined criteria established by its creators billions of years ago. The assessment criteria that such surveillance might employ could include technological development rates, environmental stewardship, social organization patterns, and conflict resolution capabilities. Human civilization's current trajectory includes both remarkable achievements and catastrophic risks that might register as concerning developments to advanced observers. Our nuclear weapons, climate modification, and resource depletion patterns might indicate a civilization approaching critical decision points that determine long-term survival prospects. The intervention possibilities that surveillance data might trigger range from subtle influence to dramatic contact or even preemptive action if human development is perceived as threatening to galactic civilization stability. Advanced intelligence might possess intervention capabilities that could influence human decision-making, modify technological development paths, or directly prevent catastrophic outcomes through means we cannot detect or comprehend. Such intervention might already be occurring through channels that appear natural or coincidental to human perception. The legal and philosophical implications of cosmic surveillance challenge fundamental assumptions about human autonomy and self-determination. If our species has been under observation throughout our development, questions arise about the authenticity of human achievement, the legitimacy of our decisions, and the reality of free will in a monitored environment. The psychological impact of confirmed surveillance could fundamentally alter human self-perception and social organization in ways that might themselves be part of the assessment criteria. The historical precedent analysis suggests that advanced civilizations might routinely monitor emerging intelligence as a standard practice for managing galactic ecosystem stability. If intelligence commonly develops along predictable pathways with similar risks and opportunities, surveillance of emerging civilizations might represent prudent management of cosmic resources and long-term civilization sustainability. Human development might be following patterns observed countless times before in galactic history. The communication protocols that surveillance intelligence might employ could include attempts to establish contact through channels designed to minimize psychological trauma while maximizing information transfer effectiveness. Advanced communication might employ symbolic systems, mathematical concepts, or universal principles that transcend cultural and linguistic barriers, while conveying complex information about galactic civilization, ethical expectations, and future opportunities for human development. The evolutionary implications suggest that surveillance might represent a standard phase in civilization development, transitioning emerging intelligence from isolation to awareness to eventual integration with galactic community structures. This progression might follow established protocols developed over millions or billions of years of galactic civilization management, with surveillance serving as initial assessment before more direct contact and integration processes begin. The technological acceleration that surveillance might enable could provide humanity with rapid advancement opportunities that compress normal development timelines from millennia to decades or centuries. Access to advanced physics, material science, energy systems, and computational methods could solve current challenges while creating entirely new possibilities for human civilization development. Such acceleration might be conditional on demonstrated ethical development and peaceful intentions. The ethical evaluation systems that surveillance intelligence might employ could include assessments of human treatment of other species, environmental stewardship, conflict resolution methods, and resource distribution patterns. Our current performance in these areas presents mixed results that might influence decisions about future contact, assistance, or intervention. Improvement in human ethical behavior might be prerequisite for advancing to the next phase of cosmic civilization participation. The multiple civilization coordination that galactic surveillance might require suggests complex organizational structures, managing numerous emerging intelligent species across vast distances and timescales. Earth might represent just one of many worlds under observation, with human development being assessed alongside alien civilizations facing similar challenges and opportunities. The coordination requirements for such management would exceed any human organizational capability by factors we cannot comprehend. The temporal patience that surveillance intelligence demonstrates suggests either biological longevity, far exceeding human lifespans, or technological civilization, persistence that maintains continuity across geological timescales. Such persistence would indicate successful resolution of the existential risks that currently threaten human civilization, providing evidence that long-term survival and development are possible for intelligence that makes appropriate choices during critical development phases. The decision-making frameworks that surveillance intelligence might employ could include complex ethical algorithms that weigh intervention benefits against autonomy preservation, guidance advantages against natural development authenticity, and individual civilization needs against galactic ecosystem requirements. These frameworks might operate according to principles developed through millions of years of experience managing emerging civilizations across countless worlds. As we prepare to conclude our investigation with reflections on what these possibilities might mean for humanity's future, remember that surveillance represents only one of many potential explanations for 3I Atlas's unusual characteristics. The implications explored here push the boundaries of speculation far beyond what current evidence supports. Yet contemplating such possibilities serves valuable purposes in expanding our thinking about cosmic relationships, intelligence distribution, and humanity's potential future in a universe that might be far more complex and populated than our current scientific paradigms acknowledge. The investigation into what NASA scientists might not be telling us about 3I Atlas ultimately returns us to fundamental questions about humanity's place in the cosmic order and our preparedness for revelations that could transform our understanding of existence itself. Whether 3I Atlas represents natural phenomena with exotic properties, artificial technology from ancient civilizations, or active surveillance by contemporary intelligence, the implications force us to confront assumptions about cosmic isolation, technological development, and species maturity that underlie our current worldview. The readiness assessment for extraordinary revelations reveals concerning gaps in human institutional capabilities and social cohesion. Our species demonstrates remarkable scientific and technological achievements alongside persistent conflicts, resource competition, and ideological divisions that might concern any advanced observers. The contrast between our sophisticated observational instruments and our primitive conflict resolution methods highlights developmental imbalances that could influence how cosmic civilization might assess our readiness for broader participation in galactic communities. The information management challenges that extraordinary discoveries would create exceed current institutional capabilities for maintaining social stability while enabling scientific progress. The classified research programs and information control measures allegedly surrounding 3I Atlas suggest recognition that certain types of knowledge might require careful introduction to prevent social disruption, economic chaos, or political instability. Balancing transparency with responsibility becomes crucial when discoveries challenge fundamental assumptions about reality. The technological acceleration opportunities that advanced knowledge might provide could compress normal human development timelines from centuries to decades, creating unprecedented opportunities alongside extraordinary risks. Access to exotic physics, material science, or energy systems could solve current challenges, while creating entirely new categories of existential risks. Managing such acceleration requires wisdom and institutional maturity that humanity has never before needed to demonstrate at planetary scales. The philosophical transformation that confirmed cosmic intelligence would create challenges every religious, scientific, and cultural framework that assumes human uniqueness or centrality in cosmic purpose. The psychological adaptation required for accepting our role as emerging, rather than advanced intelligence, would affect individual identity, social organization, and species-level self-perception in ways that might themselves influence our suitability for cosmic citizenship. The diplomatic preparation for potential contact scenarios reveals complete absence of established protocols, legal frameworks, or institutional authority for managing humanity's first communication with non-human intelligence. The United Nations, individual nations, scientific institutions, and religious organizations all lack clear mandate or capability for representing human interests in cosmic diplomatic contexts. Developing such capabilities requires unprecedented cooperation levels that current political systems struggle to achieve. The security implications of advanced surveillance or contact extend beyond traditional military concerns to include information security, cultural preservation, and species autonomy that require entirely new defense concepts. Protection against advanced intelligence might require cooperation levels, resource allocation, and strategic thinking that exceed current human capabilities. Alternatively, such protection might prove impossible, making cooperation and positive relationship development our only viable security strategy. The economic transformation that advanced technology access would create could obsolete current financial systems, resource distribution methods, and work organization patterns that form the foundation of human civilization. Post-scarcity, economics enabled by advanced energy systems or manufacturing methods would require social reorganization, more fundamental than any historical revolution. Managing such transitions requires planning and cooperation capabilities that current institutions lack. The cultural evolution that cosmic perspective would accelerate might preserve essential human values while transforming social organization, individual identity, and species-level goals in directions we cannot predict. Maintaining cultural diversity and individual autonomy while adapting to cosmic civilization requirements presents challenges that no terrestrial culture has faced. The balance between adaptation and preservation might determine what aspects of humanity survive into cosmic phases of our development. The educational revolution required for preparing future generations for cosmic participation would need to begin immediately, even without confirmation of extraordinary discoveries. Current educational systems focused on terrestrial challenges and human-centric perspectives inadequately prepare individuals for thinking at cosmic scales. Managing advanced technologies or participating in civilization networks spanning galactic distances and geological timescales. The research prioritization decisions that potential cosmic intelligence would create require balancing immediate human needs against long-term species development requirements. Scientific resources currently devoted to terrestrial problems might need redirection toward understanding cosmic civilization patterns, advanced technology principles, and intelligence development pathways that could determine humanity's future opportunities and survival prospects. The ethical evolution that cosmic civilization participation would require might demand moral sophistication exceeding current human capabilities. Advanced intelligence operating across galactic scales and geological timescales would likely employ ethical frameworks that balance individual rights against cosmic ecosystem requirements, immediate needs against long-term consequences, and species interests against galactic civilization stability. Developing such ethical sophistication requires moral development that current human cultures have never achieved. The temporal perspective adjustment that cosmic awareness would create challenges human focus on immediate concerns and short-term thinking that might appear primitive to intelligence operating across million-year planning horizons. Developing long-term thinking capabilities while maintaining responsiveness to immediate needs requires cognitive flexibility that current human psychology struggles to achieve. The cooperation requirements for cosmic civilization participation might exceed current human capabilities for managing conflict, sharing resources, and coordinating decision-making at planetary scales. Advanced intelligence would likely expect emerging civilizations to demonstrate internal cooperation before accepting them as reliable partners in galactic-scale cooperation efforts. A current record of international cooperation provides mixed evidence of such readiness. The responsibility acceptance that cosmic citizenship would entail includes stewardship obligations for galactic ecosystem stability, emerging civilization guidance, and long-term cosmic resource management that extend far beyond current human responsibilities. Such obligations require wisdom, commitment, and capabilities that humanity has never needed to develop at such scales. The uncertainty navigation skills that cosmic knowledge would require include comfortable operation with incomplete information, probabilistic reasoning across unprecedented scales, and decision-making under uncertainty levels that could determine civilization survival. Current human cognitive limitations and psychological biases might inadequately prepare us for managing such uncertainty levels, while maintaining effective function. The hope preservation that cosmic perspective enables suggests that contact with advanced intelligence, if it occurs, might represent opportunity rather than threat for species that demonstrate appropriate readiness. The vast scales of cosmic civilization could provide resources, knowledge, and development opportunities that exceed human imagination, while preserving what makes us uniquely valuable contributors to cosmic intelligence diversity. As we conclude this investigation into what NASA scientists might not be telling us about 3I Atlas, remember that the most profound discoveries often emerge not from confirmation of expectations, but from willingness to consider possibilities that exceed current understanding, while maintaining rigorous commitment to evidence and truth. The silence surrounding certain aspects of 3I Atlas research speaks volumes about the magnitude of what might remain hidden. In an era of unprecedented scientific transparency, where astronomical discoveries typically generate immediate global discussion and collaborative analysis, the reported information restrictions and classification protocols suggest discoveries that challenge institutional comfort zones and social readiness assessments. The pattern of partial disclosure that allegedly characterizes 3I Atlas information management reflects sophisticated understanding of how revolutionary knowledge affects social stability. Complete transparency might overwhelm human cognitive and institutional capacity for managing paradigm shifts, while complete secrecy might prevent necessary preparation for cosmic realities that require adaptive response. The balance between revelation and protection might itself represent advanced knowledge about how intelligent species successfully navigate transitions from cosmic isolation to cosmic awareness. The professional community divisions that classified research allegedly create present unprecedented challenges for scientific progress and peer review processes. Science advances through open debate, independent verification, and competitive analysis that requires free information access. The reported restrictions fragment the research community into groups with different information access levels, potentially compromising the verification processes that ensure scientific reliability, while creating competitive advantages that might influence research direction and conclusions. The international cooperation requirements that extraordinary discoveries would demand exceed current diplomatic capabilities for managing global challenges. Climate change, nuclear weapons control, and economic coordination provide mixed evidence of humanity's readiness for managing challenges that could determine species survival. Cosmic discoveries with strategic implications would require cooperation levels that current political systems struggle to achieve even for terrestrial challenges with clear immediate consequences. The timeline pressures that potential cosmic contact scenarios would create allow limited opportunity for gradual social adaptation and institutional preparation. Unlike historical paradigm shifts that unfolded across generations, contact with advanced intelligence might require immediate response capabilities that exceed human preparation timeframes. The reported urgency in 3I Atlas institutional responses might reflect recognition that preparation windows could close rapidly if current observations represent precursors to more direct contact. The cognitive adaptation challenges that cosmic perspective would create exceed normal human psychological flexibility for managing worldview changes. Individual identity, cultural meaning systems, and social organization patterns, developed under assumptions of cosmic isolation, might require fundamental reconstruction if cosmic intelligence proves common and accessible. The psychological support systems needed for such transitions don't currently exist at scales that could serve global populations. The technological dependency risks that advanced knowledge access would create might accelerate human development beyond our capacity for managing the social and ethical implications of such advancement. Historical precedents show technology advancing faster than wisdom, creating capabilities that exceed human judgment abilities. Cosmic technology access might amplify these risks to existential levels, while providing benefits that make such risks difficult to avoid. The verification impossibility that claims about extraordinary discoveries present creates unprecedented challenges for distinguishing truth from speculation, authentic information from disinformation, and genuine concern from unfounded anxiety. Without direct access to classified research or independent observation capabilities, public assessment of extraordinary claims must rely on institutional credibility, logical analysis, and pattern recognition that might prove inadequate for evaluating unprecedented phenomena. The responsibility distribution that cosmic awareness would require challenges current assumptions about individual versus collective decision-making authority for species-level choices, decisions that could affect humanity's cosmic status or relationship with advanced intelligence, exceed the authority of any current institution, while requiring expertise and perspective that current democratic processes cannot easily provide. Developing appropriate decision-making frameworks requires institutional evolution that current political systems resist. The cultural preservation needs that cosmic integration would create require careful balance between adaptation to cosmic civilization requirements and maintenance of essential human values and characteristics. Advanced intelligence might value diversity among emerging civilizations, making cultural homogenization counterproductive. Alternatively, cosmic citizenship might require conformity to universal standards that could eliminate distinctive human characteristics we consider essential to our identity. The investigation into what NASA scientists might not be telling us about 3I Atlas reveals patterns of institutional response, information control, and research prioritization that extend far beyond what routine astronomical discoveries typically generate. Whether these patterns reflect genuine extraordinary discoveries, prudent preparation for unprecedented possibilities, or systematic overreaction to unusual but natural phenomena, they provide insights into how human institutions respond when confronted with cosmic mysteries that challenge established paradigms. The documentary evidence available through public channels tells only part of the 3I Atlas story. Official publications emphasize the object's unusual but natural characteristics, while maintaining reassuring messages about its harmless passage through our solar system. Missing from this narrative are the institutional responses, classification protocols, and international coordination efforts that suggest recognition of implications extending far beyond routine scientific discovery. The observational anomalies described by sources within the research community, if accurate, would represent phenomena that challenge current understanding of how natural objects behave in interstellar space. Thermal signatures that suggest active heat sources, radio emissions that display artificial characteristics, trajectory modifications that exceed natural force explanations, and chemical signatures that indicate exotic processes would collectively point toward artificial origin or exotic physics that current science cannot adequately explain. The technological implications that such anomalies would create could revolutionize human understanding of physics, material science, energy generation, and space travel, while providing unprecedented opportunities for technological advancement. The alleged institutional preparation for managing such discoveries suggests recognition that 3I Atlas research might yield insights capable of transforming human civilization in ways that require careful management to prevent social disruption or competitive conflicts. The international response patterns that extend beyond scientific collaboration into intelligence, defense, and diplomatic channels suggest global recognition that 3I Atlas implications transcend pure scientific interest. The involvement of security agencies, defense contractors, and military research organizations indicates either concerns about potential threats or recognition of strategic opportunities that could affect national and international relationships. The information architecture surrounding 3I Atlas research, with its alleged classification levels, compartmentalized access, and publication restrictions resembles response patterns for discoveries with national security implications rather than routine astronomical phenomena. This institutional treatment suggests either genuine extraordinary characteristics or systematic overreaction based on caution interpretation of unusual but ultimately natural properties. The speculation explored throughout this investigation pushes far beyond what current evidence supports, venturing into scenarios involving ancient artificial intelligence, active surveillance by cosmic civilizations, and technology that exceeds human comprehension. These possibilities remain speculation rather than established fact, but they illustrate the kinds of questions that arise when astronomical observations appear to exceed natural explanation boundaries. The philosophical implications that confirmed artificial origin would challenge fundamental assumptions about human uniqueness, cosmic isolation, and species destiny that underlie current cultural, religious, and scientific worldviews. The adaptation required for accepting our status as emerging, rather than advanced intelligence, would affect every aspect of human self-perception and social organization in ways that might determine our success in cosmic civilization. The preparedness assessment for extraordinary revelations reveals significant gaps in human institutional capabilities, social cohesion, and psychological readiness for managing paradigm shifts that could affect species survival. Current performance in international cooperation, environmental stewardship, and conflict resolution provides mixed evidence of our readiness for cosmic citizenship responsibilities that advanced intelligence might expect from emerging civilizations. The uncertainty navigation skills that cosmic contact scenarios would require exceed current human comfort with incomplete information, probabilistic reasoning, and decision-making under unprecedented uncertainty levels. The cognitive flexibility needed for adapting to cosmic perspective while maintaining effective function represents psychological challenges that current human experience hasn't prepared us to handle at species scales. The timeline considerations that potential contact scenarios would create allow limited opportunity for gradual preparation and social adaptation to cosmic realities. Unlike historical paradigm shifts that unfolded across generations, cosmic contact might require immediate response capabilities that exceed current institutional and psychological preparation capabilities, making advanced preparation crucial for successful adaptation. Hidden within the routine bureaucracy of space agencies and research institutions lie document trails that reveal more through their absences than their contents. Freedom of Information Act. Requests for 3I Atlas materials return heavily redacted pages where key technical details should appear. Budget line items reference unnamed special projects, with funding levels that exceed normal astronomical research by orders of magnitude. Personnel records show researchers transferred to undisclosed assignments or granted security clearances typically reserved for defense contractors rather than university astronomers. The classification system that allegedly governs 3I Atlas documentation employs categories not found in standard government secrecy protocols. References to xenological materials assessment and non-terrestrial technology evaluation appear in partially released memoranda that suggest institutional preparation for managing discoveries that extend beyond natural phenomena. These classification categories would represent unprecedented expansion of government secrecy into domains that science fiction writers explore more often than government bureaucrats. Congressional budget oversight documents allegedly contain line items for interstellar object response capabilities that require specialized facility construction, equipment procurement, and personnel training. The funding sources include departments not typically involved in astronomical research: Defense Advanced Research Projects Agency, Intelligence Advanced Research Projects Activity, and classified programs within the Department of Energy that focus on exotic physics research rather than conventional space science. Executive branch communications allegedly include briefing schedules and classified status updates related to 3I Atlas that involve cabinet-level officials rather than mid-level science administrators. Presidential daily brief summaries reportedly contain 3I Atlas status updates alongside traditional national security topics, suggesting either systematic overreaction to natural phenomena or recognition of strategic implications that warrant highest-level attention. International treaty documentation allegedly includes classified annexes addressing information sharing protocols for discoveries that might represent non-human technology or intelligence. These treaty modifications would create legal frameworks for managing extraordinary discoveries while maintaining alliance relationships and preventing competitive conflicts over access to potentially revolutionary technologies. The existence of such frameworks suggests either remarkable foresight or advanced knowledge of discovery possibilities that require predetermined management protocols. Corporate partnership agreements allegedly extend beyond normal government-industry research contracts to include intellectual property arrangements for technologies that may not originate from terrestrial sources. These agreements would create legal structures for managing technology transfer from potentially artificial sources, while balancing commercial development opportunities against national security concerns and international cooperation requirements. The legal precedent research that allegedly surrounds 3I Atlas involves constitutional scholars, international lawyers, and space law specialists, addressing questions about jurisdiction, authority, and rights regarding potentially artificial objects of unknown origin. These legal consultations suggest preparation for managing discoveries that existing law doesn't adequately address, requiring new legal frameworks for unprecedented situations. Academic freedom restrictions allegedly affect researchers involved in 3I Atlas analysis through publication review requirements, international travel limitations, and communication monitoring that exceed standard security measures for scientific research. Universities participating in classified research typically maintain clear boundaries between secret and open research, but 3I Atlas work reportedly requires restrictions that affect entire research careers rather than individual projects. The document preservation protocols allegedly applied to 3I Atlas materials include requirements for maintaining records in secured facilities with access controls that exceed normal classified research standards. These protocols suggest either information value that warrants extraordinary protection or concerns about information leakage that could affect national security, international relationships, or social stability. Insurance and liability considerations allegedly address potential consequences of 3I Atlas research that extend beyond normal scientific research risks. Coverage for first contact scenarios, technology contamination, and social disruption from extraordinary revelations would represent insurance categories that don't currently exist in standard risk assessment frameworks, suggesting institutional preparation for managing consequences that normal science doesn't produce. Personnel psychological evaluation programs allegedly screen researchers for ability to handle paradigm-shifting discoveries and non-terrestrial contact scenarios. These evaluations would assess psychological stability, information security reliability, and adaptability to worldview changes that could affect research effectiveness and information security. Such screening suggests either recognition of psychological demands that exceed normal scientific research, or systematic preparation for managing information with unprecedented social implications. Emergency response protocols allegedly include procedures for information containment following extraordinary discovery confirmation and social stability maintenance during paradigm transitions. These protocols would coordinate between multiple government agencies, international partners, and civilian institutions to manage public information flow and social responses to discoveries that could affect civilization stability. The existence of such protocols suggests either systematic over-preparation or recognition of risks that extraordinary discoveries pose to social order. The historical precedent analysis that allegedly informs 3I Atlas response planning examines how past civilizations manage contact with more advanced cultures, how society is adapted to revolutionary technological changes, and how information control affects social stability during crisis periods. This analysis would inform strategies for managing contemporary challenges that lack direct historical precedents, but share characteristics with transformative historical events. The information landscape surrounding 3I Atlas reveals sophisticated manipulation techniques that extend far beyond normal science communication strategies. Analysis of media coverage patterns, social media discussion trends, and public opinion polling suggest coordinated efforts to shape public perception in directions that minimize anxiety while preventing detailed investigation into anomalous aspects of the discovery. These information management campaigns employ techniques more commonly associated with political propaganda than scientific education. Social media monitoring allegedly tracks public discussions about 3i Atlas, using artificial intelligence systems that identify emerging conspiracy theories, gauge public anxiety levels, and detect information leaks from classified research programs. This monitoring would enable real-time adjustment of information release strategies, targeted counter-messaging to address problematic rumors, and early warning systems for social stability threats that excessive speculation might create. The algorithmic manipulation of information flows allegedly employs artificial intelligence to promote certain interpretations of 3i Atlas, while suppressing others through search result optimization, social media content promotion, and automated fact-checking systems. These manipulation techniques could influence public opinion without direct censorship by making certain information more visible and accessible while making other information harder to find and verify. Disinformation campaigns allegedly include deliberate release of false information designed to discredit legitimate concerns about 3i Atlas by associating them with obviously ridiculous claims. This technique, known as poisoning the well, makes serious questions appear foolish by surrounding them with deliberate nonsense that discredits all alternate interpretations through guilt by association. Professional reputation management allegedly targets researchers, journalists, and commentators who raise questions about official 3i Atlas narratives. Through career pressure, funding restrictions, and social ostracism within professional communities, these techniques could suppress independent investigation without direct censorship, by making questioning official narratives professionally costly for academics and journalists, whose careers depend on institutional approval. The psychological profiling of public response allegedly employs focus groups, polling data, and behavioral analysis to determine optimal information release strategies that maintain social stability while preventing panic or excessive curiosity about classified aspects of 3i Atlas research. This profiling would enable precise calibration of information flow to achieve desired psychological effects in target populations. Media training programs allegedly prepare scientists and officials for managing public communication about 3i Atlas through techniques that emphasize certain aspects while deflecting attention from others. This training might include strategies for redirecting questions, managing emotional responses, and maintaining consistent messaging across multiple spokespersons and media appearances. International coordination of information strategies allegedly ensures consistent messaging about 3i Atlas across different nations and cultures, despite varying political systems, media environments, and public attitudes toward government authority. This coordination would prevent inconsistencies that might reveal classified information or create diplomatic tensions between allied nations managing shared secrets. The cognitive psychology research that allegedly informs 3i Atlas information management studies how humans process paradigm-shifting information, adapt to worldview changes, and maintain psychological stability when confronted with information that challenges fundamental assumptions about reality. This research would enable optimization of information release strategies to minimize psychological trauma while maximizing public acceptance of new realities. Educational curriculum development allegedly includes preparation for gradually introducing cosmic perspective concepts into school systems without explicitly referencing 3i Atlas or other specific discoveries. This gradual preparation might help future generations adapt more easily to eventual revelations about cosmic intelligence or advanced technology, while maintaining current social stability. Religious community engagement allegedly involves consultations with theological scholars and religious leaders about how various faith traditions might adapt to confirmed existence of advanced non-human intelligence. These consultations would help predict and manage religious community responses to extraordinary revelations while potentially enlisting religious institutions as partners in maintaining social stability during paradigm transitions. Cultural influence operations allegedly employ entertainment media, documentary programming, and science fiction content to gradually introduce concepts related to interstellar travel, ancient civilizations, and advanced technology. This cultural preparation might desensitize populations to extraordinary possibilities while maintaining plausible deniability about specific discoveries or classified research programs. The behavioral economics research that allegedly supports 3i Atlas information strategy studies how humans make decisions under uncertainty, process risk information, and respond to authoritative communications about complex technical subjects. This research would enable optimization of information presentation to achieve desired behavioral responses, while minimizing panic or inappropriate risk assessment by general populations. If 3i Atlas represents contact with cosmic intelligence, it arrives at a moment when humanity faces evolutionary pressures that could determine our species' long-term survival prospects. Our technological capabilities have reached levels that could enable either rapid advancement toward cosmic civilization or catastrophic self-destruction within decades. The timing of this alleged contact raises profound questions about whether advanced intelligence intervenes during critical evolutionary phases, or whether reaching such phases naturally attracts cosmic attention. The Great Filter hypothesis suggests that most intelligent species encounter insurmountable barriers that prevent their development into spacefaring civilizations. Human civilization currently faces several potential filters: nuclear warfare, climate change, artificial intelligence risks, biological weapons, resource depletion, and social collapse from inequality or ideological conflict. Advanced intelligence capable of interstellar travel would have successfully navigated similar challenges, potentially offering guidance or assessment of our survival prospects. The developmental psychology that allegedly applies to species evolution suggests that intelligent civilizations progress through predictable stages with characteristic risks and opportunities at each phase. Current human development might represent a critical transition period where species either mature into cosmic citizenship or succumb to evolutionary pressures that eliminate most intelligent species before they achieve interstellar capability. Technological singularity theories propose that artificial intelligence development could rapidly exceed human intelligence, creating opportunities for unprecedented advancement or existential risks that could eliminate human relevance in cosmic affairs. Advanced cosmic intelligence might possess perspectives on artificial intelligence development that could guide hidden decisions during this critical transition period, assuming such guidance serves broader cosmic civilization interests. The social organization challenges that cosmic perspective creates require institutional evolution beyond current human political systems, managing resources at planetary scales, coordinating decisions that affect species survival, and balancing individual rights against collective needs. Demand governance capabilities that current democratic and authoritarian systems struggle to achieve. Advanced intelligence might assess our political evolution as prerequisite for cosmic citizenship. Environmental stewardship capabilities demonstrate species maturity in managing planetary ecosystems that support technological civilization. Our current performance in climate management, biodiversity preservation, and sustainable resource use provides mixed evidence of readiness for cosmic civilization membership. Advanced intelligence might evaluate environmental management as indicator of species wisdom and long-term viability. The ethical evolution that cosmic citizenship requires might demand moral sophistication that considers consequences across geological timescales and galactic distances. Current human ethics focus primarily on immediate consequences and limited stakeholder groups, potentially appearing primitive to intelligence operating with million-year planning horizons and responsibility for managing cosmic ecosystem stability. Conflict resolution capabilities at planetary scales demonstrate species readiness for managing disagreements without destructive warfare that could threaten cosmic civilization stability. Our current record of international cooperation and peaceful dispute resolution provides evidence of progress alongside persistent failures that might concern cosmic intelligence, assessing our readiness for broader participation in galactic communities. The information processing evolution that contact would require exceeds current human cognitive capabilities for managing complexity, uncertainty, and rapid change across unprecedented scales. Advanced intelligence might assess our information processing capabilities as limiting factors in species development that require enhancement before we can effectively participate in cosmic civilization networks. Communication evolution beyond terrestrial language limitations would enable participation in information exchange networks, spanning interstellar distances and involving multiple species with different cognitive architectures. Current human communication systems evolved for terrestrial needs, potentially requiring fundamental enhancement for cosmic civilization participation. The philosophical integration challenges that confirmed cosmic intelligence would affect every aspect of human worldview, from individual identity to species purpose. Advanced intelligence might assess our philosophical flexibility as indicator of readiness for accepting our role in cosmic intelligence hierarchies, while maintaining essential human characteristics that contribute to cosmic civilization diversity. Risk assessment capabilities that cosmic perspective requires include comfortable evaluation of consequences across timescales and probability ranges that exceed current human experience. Managing risks that could affect species survival across thousand-year timescales requires decision-making capabilities that current human psychology and institutions struggle to achieve effectively. The cultural evolution acceleration that contact would create might compress normal adaptation timescales from centuries to decades, requiring unprecedented flexibility in social organization, value systems, and individual identity. Advanced intelligence might assess our cultural adaptability as a prerequisite for managing rapid changes that cosmic citizenship would require without losing essential human characteristics. As 3i Atlas continues its journey through our solar system, approaching perihelion and eventual departure back into interstellar space, the questions raised by this investigation remain unresolved. Whether this ancient wanderer represents natural phenomena with exotic properties, artificial technology from distant civilizations, or active surveillance by cosmic intelligence, its passage through our cosmic neighborhood has revealed as much about human institutional responses to extraordinary possibilities as about the object itself. The official narrative maintains that 3i Atlas represents a natural, though unusual, interstellar comet that poses no threat, while providing valuable scientific insights into chemistry and processes around distant stars. This explanation remains consistent with most available evidence, and should be accepted until contradicted by more compelling observations or analysis. Yet the patterns of institutional response, information control, and international coordination alleged by sources within the research community suggest recognition of implications that extend far beyond routine scientific discovery. Whether these responses reflect genuine extraordinary characteristics, prudent preparation for unprecedented possibilities, or systematic overreaction to unusual natural phenomena, they indicate that 3i Atlas has generated concerns and interests that official statements don't fully acknowledge. The speculation explored throughout this investigation represents mental exercises in possibility rather than established fact. The scenarios involving artificial technology, ancient surveillance systems, and cosmic intelligence remain unsupported by publicly available evidence. Their value lies not in their probability, but in their illustration of how quickly human understanding might need to adapt if our assumptions about cosmic isolation prove incorrect. The preparedness questions that such speculation raises deserve serious consideration regardless of 3i Atlas's ultimate nature. Humanity's readiness for extraordinary revelations, our institutional capabilities for managing paradigm shifts, and our psychological flexibility for adapting to cosmic perspective represent important assessments that could determine our success in navigating future challenges, whether they involve artificial objects, environmental changes, or social evolution. The cosmic perspective that 3i Atlas provides reminds us that we inhabit a universe far larger, older, and potentially more complex than daily experience suggests. Whether this ancient visitor carries messages from distant intelligence or simply represents the wandering debris of planetary formation around alien stars, it connects us tangibly to processes that span galactic distances and geological timescales. The investigation into what NASA scientists might not be telling us ultimately returns us to fundamental questions about truth, transparency, and trust in institutions managing information that could affect human understanding of our place in the cosmos. The balance between revelation and responsibility, between scientific openness and social stability, represents challenges that democratic societies must navigate when confronted with discoveries that challenge established worldviews. As 3i Atlas fades from view, disappearing back into the stellar backdrop from which it emerged, it leaves behind questions that will outlive its brief passage through our cosmic neighborhood. Whether those questions represent genuine mysteries that challenge human understanding, or simply reflect our tendency to find patterns and purpose in natural phenomena that operate according to laws we don't yet fully comprehend. They remind us that the universe remains capable of surprising us in ways that exceed our current imagination. The gentle fade that accompanies 3I Atlas's departure carries no dramatic revelations, no confirmed contact with cosmic intelligence, no revolutionary technologies that transform human civilization overnight. Instead, it offers subtler gifts: expanded perspective on cosmic scales, recognition of our limitations in understanding natural processes, and appreciation for the remarkable capabilities that human institutions demonstrate when confronted with unprecedented challenges. Good night, Cosmic Wanderer. Thank you for the questions, the speculations, and the reminder that the universe holds mysteries we have not yet learned to ask about properly. Safe travels on your continued journey through the galaxy, carrying whatever secrets and ancient memories remain locked within your nucleus. Until we encounter your successors from other distant systems, other ancient epochs, other corners of the cosmic wilderness that surrounds our remarkable but modest planetary home.